Did you turn in your warm-ups from last week? So last call. Make sure you do that. Second thing, simplifying radicals from the last couple days. This is due. Make sure you turn that in. Okay, using all those simplifying radical notes we did. In 2 days, we have a quiz on Pythagorean theorem. We'll talk about it today. Not going to be too hard. Okay. Next Tuesday is something, you know, no big deal. No big deal. That's all I'm saying. All right. But for real, let's talk about this warm-up. Now, if you read it, it tells you exactly what you need to know. A Pythagorean triple. If you've never heard that, no sweat. But it tells you that the numbers 3, 4, and 5 can make a right triangle for sure. Okay? So, 3 and 4, if they are the legs, the hypotenuse will always be 5. Okay? That's called a Pythagorean triple because they're whole numbers, no decimals, no radicals. And it works for any multiple. Y'all know multiples are when you multiply, right? So if I multiply 3, 4, and 5 by 2, that makes a right triangle. If I multiply 3, 4, and 5 by 100, that makes a right triangle, okay? So let's look at number 1. If I know 3, 4, and 5 make a right triangle, and here's 3, and here's 5, what is this missing leg going to be? 4. It's a 3, 4, 5. Easy, right? Like, this is stuff you don't have to do any math on if you just know 3, 4, 5 works. A multiple of 3, 4, and 5, if you multiply them all by 2, would be 6, 8, 10. So look at number 2. 6 and 8, what's that hypotenuse going to be? 10, because it's a 3, 4, 5 with a multiple of 2, right? Okay, what if the multiple is, or what if 3, 4, 5 are multiplied by a 10? I would have a 30, 40, 50 triangle. Look at number 3. I see 40, I see 50. Well, it's got to be 30. It's a multiple of 10. Okay, you see how you can use 3, 4, 5, but please be careful. 5 has to be the hypotenuse, not a leg. And if you don't know what I'm saying, well, I'll explain it right now because we got notes. Pythagorean theorem. Who's done Pythagorean theorem before? Anybody use a squared plus b squared equals c squared before? Okay. You should have. And if you don't remember, that's why we're reviewing it. For some of us, we're learning it for the first time. Either way, we're going to get it. All right. Oh yeah, after the notes, we'll look at that so I can fix it. Okay, I'll forget. All right, here we go. At the top here, Pythagorean theorem. Hopefully y'all have heard of this before. It's named after a guy named Pythagoras. You didn't get one? Okay. There's only one. Wait, hey. Okay, and headphones, please, in the back. All right, so, ready? All right, please. Now, first things first, Pythagorean theorem, it says it's used to find the missing, and it's used to find a missing side of a right triangle. Please notice it only works for a right triangle. You got to see that 90-degree angle somewhere, somehow. Okay. A and B are called legs. Just like you got 2 legs, a right triangle has 2 legs. Except the 2 legs make 90 degrees. So imagine standing at 90 degrees. Awkward. Okay, but that's what it looks like. Side C is called the hypotenuse. Hypotenuse. Hypotenuse is always across from 90. All right, let's actually write that down off to the side here. So the hypotenuse is across from 90 degrees, and it is the longest side. So whenever you have three numbers, the biggest number goes to the hypotenuse, across from 90 degrees. All right, so for any right triangle, it is a squared plus b squared equals c squared. That is the Pythagorean theorem. Get that down, and we'll try 4 examples together. If you've learned this before, the only thing that might be a little different is how do you write your answer. So I'm going to show you the 2 ways right now. Ready? Number 1. It says find the missing side of a right triangle. That's Pythagorean theorem. It even says to use the Pythagorean theorem. But how do we give our answer? It says to round your answer to the nearest hundredth. When it says around, that means you are getting a decimal answer, right? A decimal answer, right? So that means you can put your final answer in the calculator and give me the decimal and just round it, okay? So number 1 and 2, you're not doing a factor tree. Remember that from last week? Factor tree, circle your pairs, all that stuff. 1 and 2, don't do that. So here we go. Number 1, I'm going to write down the Pythagorean theorem because I have a missing side of a right triangle. I would like for you to label A, B, and C until you for sure know where they are. So look, A and B are right next to 90. So here's 90, so this is A, this is B. In fact, you could switch it around. It could be B and A, but notice they're next to 90. I like to draw a little arrow across from 90. That's the C value. So across from 90 is your C, right? Now, can you replace A, B, and C with these values that we have labeled here? So A is 8, B is 13, C is X. 8 squared plus 13 squared equals X squared. Okay. So far, so good. Now, let's do some math. On the left side, I have 8 squared plus 13 squared. Since they're on the same side of the equal sign, you can literally just add them together, like this, 8 squared plus 13 squared. Gives me 233, okay? So I'm going to write that down. 233 equals X squared. 233 is not your answer, because look, 233 is X squared, but I'm looking for just X. So I need to get rid of the squared. How do I get rid of a square? What's the opposite of square? It's a good guess. Square root. Okay, the square root sign, which is, that's what this is, kind of, and the square cancel out. So here's how you write it. I'm going to put a little square root radical on the right and a square root radical on the left. On the right, I like to scratch them out. They cancel out, and I'm left with X. That's what I want, just an X. Now, square root of 233, you can literally just calculator it and get your answer. So you do Control X squared, 233, oh my gosh. Hit enter. There's your answer, but we need to round it to the nearest hundredth. Okay, now this is where I'm going to have to ask for you to really look over here because we tend to have issues with rounding. Let's learn rounding real quick. Let's try to understand. The hundredth place is 2 to the right of the decimal. So we got 15.26. Okay, now a lot of people just want to write 0.26. That's tough to get. But you got to look at the next number to see if it rounds. So after the 6 is a 4. Does that 4 make the 6 round up? Stay the same. Stay the same. Okay, so it will be 15.26. Okay, 15.26 because the 4 does not round it up. That's it. The only other thing you could add is units of measure if we had any. So that's it. Could you do that? On your own, hopefully. Now, number 2 has no X, but there is a big old space here. Okay, so let's go ahead and put x where there's nothing. And once again, Pythagorean theorem, a squared plus b squared equals c squared. I would like for you to label a, b, and c. Again, a and b are next to 90. You can switch a and b around as long as they're next to 90. But c, cannot draw b right now. Okay, c has to be across from 90. There it is. Okay. Now notice, this time we're not missing the hypotenuse, now we're missing a leg. So don't fall over. One laugh, one yawn. All right, well anyways, let's go ahead and fill this in. A is x squared, b is 3 squared, c is 4 squared. Oh, by the way, if you learned something from the warm-up, isn't a 3, 4, 5 triangle, like shouldn't this be a 5 right here? No, here's why. 3, 4, 5 only works when 3 and 4 are the legs. Okay? This is a 3 something else 4. You know what I'm saying? So again, this can't be 5 because the bigger number has to be the hypotenuse. So again, this is not a 3, 4, 5. It just kind of looks like it could be. Be careful. Anyways, let's do the math here. Now, notice x is on the left side of the equation instead of the right side. What we're going to do is just square those individual numbers. What is 3 squared? What is 4 squared? So hopefully you know what 3 squared is. 3 times 3 is 9, right? 4 squared, 4 times 4. No, you with the haircut, yeah. You got a nice, little. All right. Well, 4 squared, 4 times 4 is 16, right? Okay. Do not add 9 and 16. They are on different sides of the equation, right? X is on the left, 9 is on the left, but I need to get x by itself. So how do I get rid of a plus 9? What's the opposite? Minus 9, right? Minus 9 on both sides. And now I have x squared equals 7. Okay, if you put 7 as the answer, that's not it, because your last step is always to square root the squares, right? So we need to square root this side, square root this side. And now I got to ask, what is the square root of 7? Calculator, help me out here. Control x squared 7, enter. Now, what is this going to round to when I'm rounding to the hundredths? So I got 2.64. The next number is a 5. Does that round it up or stay the same? 5 or greater rounds up. Okay, so because it's 645, now it's really going to round to 2.65. Okay, 2.65 is how you round that. Okay, and that's it for 1 and 2. So I showed you one of each. I'm missing hypotenuse. Here's how you do it. I'm missing leg. Here's how you do it. Okay. So why am I going to show you 2 more examples? Because these were rounding problems, and we're going to look at 3 and 4 and see what we're going to do different. Does anyone still need these first 2? All right, moving on to 3 and 4. Same exact instructions, except it says leave your answer in simplified radical form. Y'all remember when we did factor trees and reducing radicals last week? That's called simplified radical form. So I'll show you how it looks. Let's do number 3. Label A, B, and C for me. A, B, and C. A and B are next to 90. Across from 90 is my C value. Okay. Now, by the way, do you have to label it? Well, if you know this stuff for sure, okay, then don't worry about it. But you really got to know where A, B, and C are. Okay. Now, Pythagorean theorem. A squared plus B squared equals C squared. Replace A, B, and C. So I have 4 squared plus 6 squared equals x squared. I can do the 4 squared plus 6 squared in my calculator. So this gives me 52. Is 52 the answer, or what do I need to do? Can't have a squared. I need a square root. Now, don't put it in your calculator and write a decimal, right? Okay, because it says simplified radical form right here. So that means we need to do a little vector tree for square root of 52, okay? So let's write that down, square root of 52. All right, now, I know everyone who's been here knows this. Let's see here. What do I do first? How do I break this down? So did you learn this factor tree stuff? You're good at it? No? Well, let me tell you. Here's the trick. Start with 2. 52 is even. Does it divide by 2? Yes. Okay, so 2 times what? Hey, no phone. 2 times what? 26. Yeah. If you're not sure, divide it in your calculator, okay? So 52 breaks down to 2 times 26. 26 is also even. Let's divide by 2. 2 times what? 13. 13. You can try dividing by 2 or 3 or 5 or 7 or 11, but nothing's going to work because 13 is prime. You're done. So what we had learned is you circle any pairs, right? Pair of 2, such a cute couple, but one of them is gone. So sad. Missing. All right. So we write our answer as a radical. Couples go out. Get it? Couples go out. And then the loner stays in. Get it? Loner stays in. 2 square root of 13. That's the answer, not a decimal. Do you see how the answers look different when they ask you for a different way to write the answer? Okay? Right? Now, last one. Missing side, put an X there. Let's label A, B, and C. Again, if you put A and B in different spots, I don't really mind. It's just they have to be next to 90, okay? All right, A squared plus B squared equals C squared. A is 5 squared, B is X squared, C is 11 squared. Do we know what 5 squared is? 5 times 5, 25. And if you don't know, use your calculator. 11 times 11 is 121. Solving for x, so this positive 25 needs to go. What's the opposite of positive 25? Negative or subtraction, so minus 25. 121 minus 25 is 96. Is it? Yeah. So last step, square root, right? You can't have a square, so we square root. We square root. And again, don't give me the decimal because the instructions say no decimal. They say simplified radical form. Okay, now we're going to do this factor tree a little faster here. It's even divided by 2, right? 2 times 48. That's even divided by 2, 24. That's even divided by 2, 12. That's even divided by 2, 6. That's even divided by 2, 3. Woo! As long as it's even, you keep cutting it down by 2, and then see if you can do anything else after that, right? But that's it. Okay, again, I scratched these out because they're already broken down. Do I have any pairs? Yes, I do. I have a pair of 2 here and a pair of 2 here. And I have 2 loners that don't match, right? So I'm going to write my radical. Okay. So maybe you learned in this class or another class that those pairs go out to the left and multiply. So 2 times 2 gives me 4. And then my leftovers, 2 and 3, multiply on the inside to make 6. That's how you do a factor tree, okay? Now, I'm going to give you the assignment for this. Listen, I'm going to give you the assignment for this. You'll have time today, obviously. You'll have some time tomorrow, but I'm also going to give you the review for the quiz on Wednesday tomorrow. Tomorrow is early release, shorter classes, but we're still having class, so come to class. All right, here we go.